Hello everyone, in today's video we are going to be looking at the hyperbola, and first off let's just look at our general formula. Last year we had a over x in grade 10, and then you had your plus q at the end here. So a over x plus q are the parts of the graph that you already know, and this year we are adding in a third part, which is p underneath the fraction line over here. Now before we carry on and look at our hyperbola, let's go to Geogebra to see what the effects of a, p and q are on our graph. And if you look on the graph at the top here, you can see we've got a slider with a is equal to 1. To the left, you can see we've got f of x is equal to, and you can see the general formula for our hyperbola. With our current values, you can see that our formula is 1 over x, because a in our slider is equal to 1, p in our slider is equal to 0, and q in our slider is equal to 0. So if I do that, you can now see our graph, and you can see that it is a hyperbola. Now currently it looks like that hyperbola is touching the axes, and that is where our asymptotes are. But if I come over here and I zoom in and we go up, you can see that even when I zoom in, it gets close, but it is actually not touching the axes. And this is generally what our graph looks like if we haven't any changes. So let's start with A. So looking at the formula on the left there, if I move A over, you can see that the A at the top of the formula is now 3.3, same as my slider. And so as I slide this up and down, it's going to change that value. So let's go back to one where we started. And I want you now to watch what's happening with the graph. So as I slide A to get bigger and bigger, notice that my graph appears to be moving away from my axes, both in the first quadrant and in the third quadrant. And we can go all the way up to 10. And you can see it's pulled quite far away from my axes where my asymptotes are. So if I go back to 1 where we started, there's 1. Now if we move in closer to 0, notice that this time it's pulling closer and closer. Oops, let's go back there. Closer to my asymptotes in the opposite way. So we can see when we get a value bigger than 1, our graph moves away from the asymptotes. And when we have a value between 0 and 1, our graph moves closer to our asymptotes. Now let's look at what happens when it's negative. So if I go over here to the negative side, there's our positive side, there's our negative side. Our graph jumps. So when it's positive, it's in quadrant 1 and 3, and when it's negative, it is in quadrant 2 and 4. And notice when I get numbers that are negative but get bigger than 1, it moves away from my asymptotes. And when I have a value less than 1, notice it gets closer and closer to my axes. And that is how A affects our graph. Now let's look at Q. I'm going to come back to P because P is new for grade 11. So if we look at Q, it's what we're adding on at the end. And if you remember from last year, it gives us our horizontal asymptote and it shifts our graph up and down. So let's double check that it does that. So as I may increase Q, notice my graph moves up, and you can see there should be an asymptote running there. So when I go to 4, for example, there you can see the graph is getting closer and closer to 4. But if we had to zoom in, notice it's not quite reaching 4. Then I carry on over here, and it's getting closer and closer to 4. Right, and so I can move that all the way up to 10, and notice it goes all the way up. We almost lose our graph. And then, so if I've got positive p-values, if we've got positive q-values, and notice it's changing in my formula now. I'm at q is equal to 5.6, and in my formula, I've got 1 over x plus 5.6. So my q value has changed, and it's moved the graph up as we go to our positive values. Now, if we go down to our negative values, notice it moves our graph down below the x-axis. So at 0, let's get there. At 0, we are on, our asymptote is on the x-axis. And then as I give it a negative value, it moves down below. So -5 has shifted my graph down 5 places. We kind of expect with Q, when you shift something up, you add. When you shift it down, you're subtracting from our transformations in grade 9. Now let's look at P. So P, notice I go to, let's go to +4 there. Oops, it's jumped off 4. There we go. So we've got P is equal to 4, and notice my equation has 1 over x plus 4, but notice counterintuitively, instead of my graph moving to the right as we expected, it has moved to the left. And so we have got -4 as our asymptote for the vertical equation. And so as I move it, make it more positive, notice it moves more and more to the left. So what happens if I make it a -p? Notice now it moves to my positive values. So a -p shifts my graph to the right. And my asymptote, instead of being at -6, if you look at this graph, my asymptote is at 6, at x is equal to 6. And so P is very counterintuitive. And I'm sure you saw this with your parabola also. So remember, your Q value shifts it up and down, and is very much, if I make it a positive Q, it moves up so many places. If I make it a negative Q, it moves down so many places. Whereas with P, if I make it positive, it moves left, and if I make it negative, it's moving right. Now let's take down some notes on the effects of these variables. So let's start with our variable A and its effects. So over here we have our hyperbola, and it is currently y is equal to 1 over x, which is in its original setting. And so we have our asymptotes. Over here is our first asymptote on the y-axis, where x is equal to 0, and our other asymptote is here on the x-axis, so we have y is equal to 0. And let's start with the effects of A. So if we have our graph here, if we make A bigger, then our graph is going to move further from the asymptote. So as A gets bigger than 1, notice currently A is 1. If we make it bigger than 1, it's going to move away from our asymptotes. So let's just add that on to that. And if we make A less than 1, staying in the positive A's, so we should say from 1, A is less than 1 but greater than 0 here. Okay, oops, I squished that a bit. Then our graph is going to move closer to our asymptotes. So there we go. Now that's the first part of A, but let's have another look at that a little more in detail. So over here I have my hyperbola with its 2 asymptotes. So if I say A is equal to 2 and I make it bigger than 1, we're going to have something that goes over here. Let's see if I can do that. There we go. So notice this graph pulls away. Okay. And over here we'll have the same thing at the bottom. So we have our graph, but he's pulled away from my asymptotes. If we go with a is equal to a half, which is less than 1 but bigger than 0, our graph goes closer to our asymptotes. So we get this graph that likes to stay close to our asymptotes, even here towards the middle. Okay. So there you can see the effects of A as we get further away from 1 and as we get to decimals and fractions. Now the other part of A that most of you already know from grade 10 is a positive or negative A. So here we've got positive 1, and you can see this is like our original graph where we are sitting in quadrants 1 and quadrants 3. Remember, our quadrants are labeled 1, 2, 3, and 4. So if our A is a positive A over here, then we're going to have our two pieces sitting in quadrant 1 and 2. Now I've got little marks like that by it because remember that we are looking at the quadrants according to the asymptotes, not to the axes. So if we get a negative A over here, then our graph is going to be in the other quadrant. So it's going to be over here and over here. So notice it's the flipped version. Okay, so that's been reflected down there and that one's been reflected up there. And so we get our two pieces in quadrant 2 and quadrant 4. And that is our A variable in our formula. Let's go to Q next. Okay, and the reason for that is because you have already done Q in grade 10. So I'd rather focus on what you have done, and let's bring that up a little so that we can focus on this part. So over here we're looking at Q. So if we have a positive Q, hopefully you remember from last year, it will move our graph up. Okay, so that's a positive Q over there. Okay, and it moves our whole graph up. Now the easiest way to see where it's going is looking at your asymptote. So your asymptote moves up to Q, and let's put that in there. The asymptote moves up to Q. Okay, so for example, here I've got Q is equal to positive 3. So let's say positive 3 is over here. My asymptote is going to be over here, and so my graph moves up and I've got my graph sitting there. And so now my graph goes through the x-axis because there's no longer a asymptote there, and we will have an x-intercept. If we have a negative Q, it's going to move our graph down, so a negative Q value over here, and let's just put in there that our asymptote moves to Q. The whole graph does move. So when we have a negative Q, it moves the graph down and moves the asymptote down to Q. For example, Q is equal to negative 2. So somewhere down here we've got a negative 2. The asymptote from my x-axis will move down here to negative 2, pulling my whole graph down. And so it'll push this piece down to here, and bring this piece down to there past my x-axis. So that is our Q value. So A and Q you should be familiar with from grade 10. Now we're going to look at P, which is the new value for grade 11. And as you saw in the video, it has a very counterintuitive effect on our graph. So let's move this up here so you can see the notes down here at the bottom. Right. So we saw that to move right, you've got to have a negative P. Okay, so a negative P. So it moves right, and once again, this is my asymptote, and we're talking about our asymptote here. Okay, my asymptote moves right to P times -1. Now I'm just putting this in here because not everyone is going to be able to watch the video, so they need to know that the P over here is going to become a positive P, because negative times a negative gives me a positive. So a negative P moves my graph to the right, and the asymptote will land up at P -1. For example, P is equal to -2. So -2 will be a positive 2. So over here, I have positive 2. And so my asymptote will move from the y-axis to the right. Over here, moving my whole graph to the right. And so we have our graph sitting over here. And now we get a y-intercept because our asymptote has moved off the y-intercept. So in reverse, if we want to move left, we're going to have a positive P. So make sure that you take a note of that. Notice it's the same as what was happening with your parabola. So you can make a connection between your different functions. So my asymptote moves to P -1, and that makes sense because we're now at our negative x values. So positive times a negative gives me a negative value on my x-axis. So if we look at P is equal to positive 3, we move 3 to the left, bringing us here to -3. And so my asymptote moves from the y-axis left to -3. And this moves my whole graph left. And so we have our graph over here and over here. And that is a summary of the effects of A, P, and Q on our graphs. Now let's look at the properties of our asymptotes. We've got two asymptotes. The first one is our vertical asymptote that cuts the x-axis, which is why our equation is x is equal to. Now remember, our vertical asymptote moves left or right, being affected by our p-value. And we saw already that we need to work with a negative p's. So our p-value changes its sign to wherever our asymptote will go. Now, just a reminder that if our asymptote is x is equal to 0, it will be on the y-axis. So x equal to 0 lands up on our opposite axis, our y-axis. Now, if we look at our horizontal asymptote, going this way, this one moves up and down and goes through our y-axis. And so our equation for that asymptote will be y is equal to, and q affects our up and down movement as we saw in the previous notes. So when we have y is equal to 0, our asymptote will lie on our x-axis. Keep that in mind when you are doing your exercises.